Hello, this is Edexcel C4. Got that one right this time. No, whatever year it is, January 2012, or it could be June or whatever. I don't know. I've attempted this so many times, messed it up at the start. So anyway, this question 1, I do remember the question, is about implicit differentiation. Now I've given you a little bit of a context here because obviously I've not attempted this question before and made a complete hash of it and couldn't be bothered rewriting that. No, not at all. It's to get you thinking about this term. Okay, so what we've got here is we said the curve 2x plus 3y squared plus 3x squared y equals 4x. And we've got a coordinate that we're told p is x is -1 and y is 1. Okay, so this obviously gives a bit of an idea, just a bit of an explanation. So we're asked to find the gradient at p. Now, first of all, to work out the gradient at p, we need to use a gradient function, which is dy dx, obviously. Now, what we go about doing here is, because we've got x and y, so we differentiate each term with respect to x. So if we start this. Okay, so 2x becomes 2, 3y squared doesn't become 6. Well, it becomes 6y, but not just 6y. 6y dy dx. Okay? Because it says, because we've got a put over here, so what we're differentiating 3y squared, the only thing we can differentiate 3y squared to, with respect to, is y. So therefore we apply the chain rule to this idea. So therefore dy dx, or in this case dy dx equals dy over d something times the same d something over dx. Now, the only thing, as I said, we can differentiate 3y to is y. So therefore that becomes the unknown. So that's why we end up differentiating 3y term and then put 3y squared term and putting dy dx next to it. Okay, so that's why we've got that there. Now this bit I've obviously underlined previously. 3x squared y. Now what you might end up doing is going, okay, 3x squared y, well it's got a y in there, differentiate that becomes 6x dy dx because we've got y in there. So we differentiate the whole thing because I'm lazy. Well, maths doesn't work like that, and maths wouldn't be too happy if you worked like that. So, okay, so what this is actually saying is to think about this. 3x squared times y. Now the only rule we have for differentiating one product times another product, granted this is a product of x and a product of y, but still products that we don't know, so what we do is we use the product rule. So I've already split it up for you here. So we've already said u is 3x squared, therefore u dashed, or derivative of u with respect to x, is 6x. V therefore is y. So if we differentiate y, we get 1, or the same as differentiating x, you get 1. However, because we're differentiating y, not x, we have to apply this theory over here. So instead of putting 3y squared in this bit here, for differentiating y, we'd put y. So it's dy of dy times dy dx. So therefore it's just 1 dy dx. Okay? So that's what we've put there. So therefore we have to incorporate this bit. So what I do is put a set of square brackets here. So you do a differentiation inside the differentiation bit. So therefore, remember, for this one it doesn't matter because you're adding them. But what it is so it's vu dashed plus uv dashed. Now the reason I remember it like that is because in each, it doesn't matter which way you remember this, by the way, this is completely and utterly pointless writing it down, but just for your benefit, so that equals 4 because the derivative of 4x is 4. The reason I remember this like that is because if you remember the quotient rule, this is the most difficult one to remember in terms of where to put the uv dashed. It's always, I always think of it as the last term is minus uv dashed. So therefore, think, okay, that's the last term. It doesn't matter which way, as I said, you remember that, but always remember the minus uv dashed on the quotient rule at the top of it. But as I said, that's a completely different thing, so I could just be rabbiting on about nothing. So if we input our values, so you could just ignore me there. So v, we said it was y, u dashed was 6x, so y times 6x, plus u, which we said was 3x squared, times derivative of y, which was just 1 dy dx, equals 4. Now I could see why it'd be tempting, because we've got, so if we expand this out, so therefore we've still got 2 plus 6y dy dx plus 6xy plus 3x squared. Now you can put 3x squared times 1, I'm just going to put 3x squared dy dx equal to 4. Now I could see why it'd be tempting, because we've got, you think, okay, well if you're derivative y, if you're doing the derivative of y, you're going to end up, you can't possibly end up with some function of x and then having to differentiate some function of x and then having to dy dx next to it. I mean, surely it goes against the whole concept of what I was trying to get across to you. However, you've got to remember, keep the dy dx with any term that you're differentiating y with. Here, even though we've got 6xy, yes, it's got a y in there. The only reason y is there is because we've done this separate little bit of rule here. We've done this differentiation rule, and this y is not differentiated, so you don't need to put dy dx next to it. However, because we've differentiated part of this here, we've got 3x squared times the derivative of y. The derivative of y is 1. That's essentially, so we still have to put dy dx next to it. But because we're multiplying 3x squared by 1 with respect to times dy dx, therefore it looks weird because we've got this dy dx with 3x squared. But don't let it confuse you. I mean, that's the whole idea of maths, just to confuse you, not to solve any problems. But anyway. So what we're doing here is what we talked about in the video, the implicit differentiation video, weirdly enough, is we've got to remember, because this is the d of something, so yeah, the d in this case, d3 squared y over dy times dy dx. Therefore, any term with dy dx is not 6y with respect to dy dx, because that wouldn't make sense. Because you only do it with respect to either y or x or whatever it is. You're not doing it to both. You've got to remember, this is part of the chain rule. So what we're saying is this is 6y times dy dx. It's not 6y dot dy dx. So therefore, this is the same as saying 6y times b. So if we call dy dx b, it'd be 2 plus 6y times b plus 6xy plus 3x squared times b. Because these are factors, I know this is quite confusing because we've got 6xy, but you've got to remember, this 6xy wasn't part of any implicit differentiation. We just simply did some C3, which has no implicit in it, so you don't need to worry about that. Okay? So this is 6y times dy dx. So the first thing you do is rearrange this so you get the dy dx's on one side. Now, as they're both positive, I'm going to keep them both positive. So we'll put 6y dy dx and move everything else apart from the other. So it's 6y plus 3x squared dy dx. We'll move everything over to the other side. So that is equal to 4, take 6xy, take 2. So, as we were saying, this is 6y times dy dx plus 3x squared times dy dx. Now, as we want to make dy dx a subject, we want dy dx on its own. And because it's a multiple here, we can take out dy dx as a common factor. So dy dx is equal to, if we take out dy dx as a common factor, so dy dx, take out as a common factor, 6y plus 3x squared equals 4 take 6xy take 2. So therefore, if we want dy dx on its own, it's in 6 dy dx times 6y plus 3x squared, which is just another way of saying that above. So if we divide both sides by 6y plus 3x squared, we get dy dx being equal to 4 take 6xy take 2 over 6y plus 3x squared. Okay? So very good, that's the gradient function. But we've still not answered the question. This is why it's worth a nice healthy 5 marks, because we've had to do this other bit of differentiation you might not have spotted. Okay, so if we put, because these are essentially boundary conditions, when we're saying when this is x equals -1 and y equals 1. Okay, so put it into this formula over here. So therefore, dy dx, or the gradient, is equal to 4 take 6xy, so 6 times x minus 1 times y, which is 1. So therefore, that's going to be essentially 10. But we're not going to write 4 plus 6 just yet, because I'm going to show all my working out first. So let's take 2, and remember that's all over 6y, so 6 times 1. plus 3 times minus 1 squared, which is obviously just 3. So therefore, on the top we've got 10 take 2, which is 8. 8 over 6 times 1, which is 6, plus 3 times 1, which is 9. So therefore it's 8/9. Okay, that's the gradient. So I'll just let you copy that down because we're going to move on to the next part of the question in a minute. So just as I said, I'll give you a minute to copy that down because I'm going to need to be rubbing it off to answer the next question. I've done something wrong. Sorry, I've just double checking, I'm not doing something wrong. Sorry, yeah, so you carry on doing that. 8x 6x1 plus 3x squared. For what? So 1 sec, I've just get rid of that a second. Sorry about that, guys. So if you copied that down, it's a little bit wrong. Probably because this 4 up here is not 4x, it was 4x squared, so which makes this all 8x. So wherever you saw 4, if you replace that with 8x, therefore x. And if you put this into your idea here, okay, so if you put 8 times x minus 1, therefore you should get 4/9 as opposed to 8/9 for a gradient. Okay, so sorry about that, just made a bit of a mock up there, I didn't quite read the question, but the rest of it is exactly the same. After reattempting this question about 4 times, I can't bother redoing it again, so you just live with that, because I can. So anyway, scared of too much. Thanks for watching that. I'm going to move on to part B now, so if you just give me a brief second, I'm going to pause the video. Well, pause it. I'll just be a second while I get rid of this rubbish on the board. So you might want to pause it now and have a copy all that down. But otherwise I'd just be rewriting it all and just saying the gradient is this and hoping you understand all of that. As I said, comment or whatever and I'll go through bits if you don't get it. Okay? So just be a second. Okay, so you see it's a lot better now. What I've done is rewrite all the key bits of information. So ideally this is what your part B starting should look like. So you should have your gradient here. You should have your gradient, what x is, what y is. You don't need all this crud here now. You can almost forget what the C equation, what the coordinates of P are, because we've wrote them down apart from this, but you don't need the equation of the line because we don't really need to understand that anymore. What we need now is to find the equation of the normal. So, sorry, I do have faith in myself for getting the question right, but I didn't last time, so. Find the equation of the normal to C at P. So we've worked out the gradient at C. So that's a gradient for the curve, or a tangent to the curve. Now as we said, I put a little thing coming down from here. In previous videos, the normal, the gradient of a normal at a given point is the negative reciprocal, has the negative reciprocals of the gradient at that point. So basically do negative reciprocal of 4/9, which is negative 9/4, which I'd put that as equal to the gradient of the normal at C, at P, sorry. At point P on curve C. Now you don't have to put all that, as I said, you just put the gradient is equal to negative 4/9. But I just like to waste some time. So we followed now the standard equation of the curve. However, before we do that, we need to remind ourselves, it's asking us to put it in the form ax plus by plus c equals 0. Now obviously that might be take away c, but that's just kind of format you want it in. Okay, so what it's saying here is if you haven't got a gradient, now this should be highlight something. If you've got a gradient that's say 3 or 4, should be ringing an alarm bell straight away. It's asking it in ax plus by plus c that you've done something wrong, because to have it in this format ax plus by plus c, you will always have a gradient which is a fraction. So therefore, instead of putting, because otherwise what you'd end up having is 3y equals 2x plus 7, for example, which isn't going to help you very much. Well, it is, but what I'm trying to say is whenever you have this ax plus by plus c equals 0, they're not just doing that for the fun of it. They'd be, well, probably are. But anyway, what I'm saying, distracting myself, is the fact that when it's in this format, it wants you to have it, it's generally going to have a fraction. But you follow the same idea for equation of a line as you did way back in C1. So y take y1 is equal to mx take x1. So that should be fairly familiar. So y take y1, that is just y minus 1. The gradient, which we said was negative 9 over 4. X take x1. Now as x1 is minus 1, take away minus 1. So you could either have one, you could put in another step, x minus minus 1, and then have the next line as y take 1, negative 9 over 4, x plus 1, but I'm just going to go straight to x plus 1. Okay, so instead of expanding this bit out like we normally would, what we're going to do is times the whole equation by 4, because we want to get rid of this fraction. Okay, otherwise it'd say ax over d. So anyway, times all of it by 4. So 4y take 4 is equal to negative 9, and then I put in brackets x plus 1, but I'm just going to expand that. So it's negative 9x take 9. Now, as it wants ax plus by plus c equals 0, we could either move the 4y minus 4, or take away 4y and add 4 to both sides, or so we could either do that or add 9x plus and 9 to both sides, which I'm going to do it the second way because I can. So what we're going to do, anything that's smarter, so add 9x both sides, it's 9x plus 4y, take 4 plus 9, so that's plus 5, equals 0. So therefore, I put a little thing saying in required form. Now obviously that second part was a hell of a lot easier, but really all it's testing is, do you remember what you did in C1? Okay, nothing more, nothing C4 about the second part of the question. It was mainly the first part that was a bit more tricky, using some of your implicit differentiation, which, as I said, that's still quite a nice 8 marks of the paper there. So, as I said, hopefully you understand that. Any comments or anything, please do let me know. As I said, hopefully that part really could have been put in a C1 part. But anyway, thanks for watching, and hopefully it's been helpful. We'll see you in the next video.